The 7000 includes powerful analysis capabilities that make it easier to capture, characterize, and analyze any signal. Add zone triggers to a standard trigger mode to include only signals of interest. Characterize signals across deeper memory using precision measurements and enhanced Keller FFTs. Analyze transients and effects like jitter and modulation using pass-fail masks and the histogram. Analyze other signal types with the 6 instrument capabilities included in the MSO7000 oscilloscopes. Let's take a look at how each of these advanced analysis capabilities makes it easier to debug your design. Zone trigger works in conjunction with a traditional trigger type, such as edge, slope, I2C, pulse, or any of the other 21 trigger types. Zone trigger looks at all the captures from the original trigger type and displays only the ones that meet the active zone criteria. This makes it simple to isolate signal artifacts with a simple touch. Here we're looking at a 1 MHz square wave that has an occasional glitch. Zoom in on it there. Now, due to the Keller gridding on the 7000, we can easily see this glitch, this aberration that's occurring. But now we want to isolate it. We can easily activate a trigger zone. And now we're capturing only the signals that intersect with that, so looking only at those dropouts. We can easily change that and capture only the ones that stay high longer. So that's an easy way between the two zones to isolate signals of interest and really capture signal artifacts, whether it be on glitches like this, serial communication packets, or a number of other complex signals. The ability to make precise measurements is an important feature of the new 7000 series oscilloscope. Let's see how that works. Here we're looking at a 25 MHz signal, but we're out at 5 milliseconds per division. So with 50 milliseconds on the display, there's 1.25 million cycles of that sine wave within the displayed data. On a normal oscilloscope, if you had measurements like this, like edges and frequency, you get undersampled data and aliasing, just like these measurements here. If we compare that to the frequency counter is accurate at 25 MHz. But the other measurements are undersampled, and that's because in this normal measurement mode, like most oscilloscopes, we're using only 1 million points of data within the displayed range. What we offer in the 7000 series is this new precision measurement mode. Now you can see those measurements changed, and that's because in precision measurement mode we use the full deep memory within the displayed data. And that, in this case, is 125 million points. So with all that data available, we're able to correctly calculate 25 MHz frequency and 1.25 million edges of the sine wave within that signal. So this is a great way to analyze hidden signals within your displayed data and make sure you're getting accurate and precise measurements. Another way we can get more out of our deep memory on our 7000 series oscilloscope is with the FFT. Here we're using our enhanced FFT and doing two important things. One, the enhanced FFT can capture up to 1 million points into each FFT. This allows us to capture the deep memory from the signal up above and put it into the spectrum. Second, we're using the Keller FFT capability to really create a max hold trace type here based on probability. So here we can clearly see the 10 MHz carrier and the FM modulation on the 3rd, 5th, 7th, and even further out, 9th harmonics. So it's a great look at really the deep memory data as we're looking through that carrier and its motion over time, capturing it in a deep memory Keller FFT. Pass-fail testing is a tried and true method of signal analysis. The 7000 series makes pass-fail analysis faster and easier thanks to the processing capabilities of the UltraVision 2 architecture. The first improvement to the pass-fail testing is speed. This signal is a 1 MHz square wave with a glitch every millisecond. So 1 out of 1,000 transitions are these short glitches. Let's enter the pass-fail menu. Go ahead and create a mask from this existing signal. Now we can go ahead and operate this menu. In this particular setup, the instrument can capture more than 100,000 waveforms every second and process them against the pass-fail mask in real time. This way you lose less events and you quickly gather statistically significant information. Additionally, we've added some options in the output as well. For pass-fail error actions, you can now capture a screenshot for each error that occurs. This is a great way to archive failures for later review and analysis. The histogram is a new analysis capability within the 7000 series oscilloscope. The histogram provides a unique visualization as well as a comprehensive data table well suited to characterizing a number of signal types. As an example, let's look at this signal that has some frequency modulation on it. If we need to characterize that modulation, we can zoom in and then use the touchscreen to create an area for our histogram. Now we're capturing those samples and looking at the deviation and the nature of the distribution of those frequencies. We can see min, max, peak, median, a bunch of data about the statistical probabilities of those differences, and we can see visually how those are bucketed out. Because I'm using the embedded generator to create this signal, we can go into the menu here and change the distribution properties. See how it changed in the color gradient there. And now let's go ahead and reset that histogram, and now it's rebucketizing with the new data, the new distribution. So you can see the difference in how that signal is put together. So you can really go ahead and analyze the nature of the frequency modulation to see whether that's a clock or some other signal interfering with your signal, or what really is causing that modulation on the embedded signal you're interested in. So that's how histogram can help you visually and from a data standpoint further analyze all of your embedded signals. In addition to the zone trigger, histogram, pass-fail, precision measurements, and enhanced Keller FFTs, the MSO7000 series also includes the capabilities of 6 instruments in one. Use the oscilloscope, logic analyzer, protocol analyzer, waveform generator, counter totalizer, and voltmeter to characterize, emulate, and analyze signals from DC to high-speed digital and everything in between. The flexibility to access these functions as needed without additional hardware makes the MSO7000 series the world's most powerful and affordable mid-range oscilloscope. A great choice for today's embedded design challenges.